Hello, everyone, and welcome to Conf42 Machine Learning. And today, in this session, we are going to explore the role of machine learning in modern payment ecosystems. This is not a talk about any specific algorithms or model architectures. Instead, we are going to take a deeper look at how machine learning is going to fit as a system in the current payment ecosystem, and the perspectives of how it fits, why it matters, and how it's transforming the modern payment ecosystem. My goal is going to be very clear, a practical understanding of how machine learning enhances payment systems, regardless of whether you're an engineer, you're a product owner, an architect, or simply interested in knowing about the future payment systems. Before we dive in, let me introduce myself. I'm Balakumaran. I work in the financial industry with over 16 plus years of experience in handling large-scale payment systems. I have spent more than a decade or more in handling payment platforms and enterprise architecture. Throughout this journey, I'll be sharing my experiences on the practical adoption of machine learning that we have experienced in production environment. What brings me to this conversation is not just about the theoretical knowledge, but real-world experience that's connecting the payment challenges along with the machine learning solutions. I've seen work, and most importantly, how machine learning is truly adding a value to the current payment solutions, and how it's just not a hype. The focus of this session is to bridge the gap between real payment challenges and applied machine learning. And we'll be examining how machine learning solutions are fit into the current payment systems, and the perspective of looking beyond mathematics and statistics that are involved in machine learning algorithms, and how machine learning capabilities integrate into a broader payment landscape and deliver a tangible business value. So what essentially are we going to cover today? So here's the agenda that we are going to cover today. We'll be understanding what is modern payment system, what is modern payment ecosystem, its inherent complexities. Then we are going to explore how machine learning basically fits into the ecosystem, the specific touch points across different payment life cycles, and where machine learning makes a difference over there. We'll also look at some of the real world examples and the key areas like merchant acquisition, transaction processing, operational decision makings. These are not just hypothetical situations or scenarios. They are based on the actual implementation that we have seen in production environment. Next, we will discuss more on the system level benefits of how machine learning algorithm works in terms of scalability, automation, and how low-level latency decision making are being handled by machine learning algorithms. The capabilities are to enable payment platforms to operate at scale, speed, with accuracy, and that's required by modern e-commerce payment systems. Finally, we'll be looking ahead in the future, like how machine learning is evolving with emerging payment technologies and challenging customer expectations. We'll also be touching on challenges and considerations that come along with machine learning algorithms in terms of biases and how we are handling in terms of the critical domain expertise that machine learning brings. Let's start by understanding what we mean by the modern payment ecosystem. When we talk about modern payment ecosystem as of today, we are not just talking about moving money from one bank to another or point A to point B. We are dealing with much more complex interconnected systems that span across multiple domains. At a high level, we are going to have merchant acquisition, the process of onboarding, underwriting new merchants, and then we go ahead with the transaction processing where payments are authorized and executed in real time. And then it comes with its own challenges of fraud detection system that needs to be continuously assessed with its risk and preventing fraudulent activity on a day-to-day basis. Settlement handles the actual movement of the funds and reconciliation across the payment network. Analytical brings business intelligence to all stakeholders, and operation ensures that platforms run smoothly, efficiently, reliably, and moreover, it builds the customer trust on using the payment system. Each of these domains have its own challenges. They bring more and more interconnectivity. A decision made in fraud detection affects authorization rates. For example, if a bad decision made by a fraud detection system may incur or cause a bad experience for customers using the payment platform, as well as the financial implications for the financial institute. Insights from analyticals also inform us more on the acquisition strategies. Operational intelligence also improves system reliability. Here are the key challenges that we are seeing today. The system must handle millions of transactions in a very short, low latency, like less than 100 milliseconds, high accuracy, and continuous adaptation to evolving patterns. Traditional rule-based approaches simply cannot handle such complexities. And that's where we see like machine learning fits into this entire picture. Now let's understand why machine learning matters. Let's contrast the traditional approach of machine learning enhanced approaches. In traditional payment systems, we relied heavily on rule-based systems with static threshold. You would have rules like decline if the transaction is over 5,000 for a new card, or flag a review if the velocity exceeds 10 transactions per hour. These rules were created by domain experts and updated periodically. Manual reviews and interventions are very common. Humans would look at flag transactions and make approval decisions. Processing often happened in batches. We would run reports at the end of the day to spot issues. The systems were very reactive to fraud patterns, meaning fraudsters often had the window of opportunity before rules were updated. This was limited to personalization. Every customer with similar characteristics got treated the same way. And perhaps more importantly, these systems were very slow to adapt to changes. Updating rules required committee meetings, testings, and deployment cycles, and a full round of loan sanity testing and exhaustive testing before it moves to the production environment. Now, on contrast to this, with machine learning enhanced capabilities, instead of static rules, we have more adaptable models that learn from continuous data. The models can process hundreds and thousands of transactions with low latency, finding patterns that humans would never spot. Decision making happens automatically at scale, millions of decisions per day, each informed by the latest data. Processing happens in real-time streams. There's no waiting for batch windows. The system are predictive and proactive, identifying potential issues as they occur, and personalization becomes possible. Each transaction is evaluated in its own unique context. Who's the user? What is its history? What's the norm for them? And the system continuously improves itself, learning from every transaction outcome. This is the fundamental shift that machine learning enables in current payment ecosystem. And that's moving from the rigid manual processing and reactive systems, make it more adaptive and an intelligent platform using machine learning. Let's go with machine learning across the different payment cycles that we have on a day-to-day basis. Let's get more specific about how machine learning fits in the payment lifecycle. I want to see that machine learning isn't just bolted on one part of the system. It touches every stage of the payment journey. Now, starting with the first stage, which is known as acquisition phase, machine learning helps with the risk scoring and KYC automation. When a merchant applies to use a payment platform, machine learning models can instantly access the risk profiles, verify their identity, and make preliminary decisions about approving and the pricing information for the customer. Now, going for the next stage of the payment lifecycle, during the authorization phase, the ML powers fraud detection at real time and optimizes routing decisions. Every transaction model evaluates fraud risk, decides whether the payment network to be used, and determines whether to approve, decline, or step up authentication. In the pre-processing phase, machine learning provides more of an anomaly detection and a load prediction. It spots unusual patterns in transaction flows, predicts more of a capacity needs, and helps in the system performance. Settlement benefits from machine learning through improved reconciliation and cash flow forecasting. Models can predict settlement times, identify discrepancies early, and optimize liquidity management. And in operations, machine learning enables performance optimization and intelligent alerting. Systems can predict where infrastructure issues might occur and automatically adjust versus maintaining to service quality. Below the lifecycle stages, we also have cross-cutting machine learning capabilities that enhances all the areas. Pattern recognition helps in identifying trends in transaction data across millions of events. Risk assessment evaluates the transaction risk in real time, considering hundreds and several factors simultaneously. The predictive analytical future also has a kind of behavioral outcomes, from fraud likelihood to merchant success rates, and optimizes constantly, improving routing decisions, resource allocation, and system performance. The key insight here is machine learning creates an intelligent layer that runs through the entire ecosystem, not just isolated packets or functionality. Now let's move on to the first stage of the payment ecosystem, which is known as the merchant acquisition. And now let's look at some concrete application examples, starting with the merchant acquisition. The challenge in traditional merchant acquisition onboarding is significant. The process is slow, manual, and inconsistent. Underwriters have to review the application one by one, evaluating business documents, financial statements, and the risk factors. This can take up to days or weeks, creating frictions for merchants who want to start accepting payments right away and quickly. Decision quality varies based on underwriter experiences and judgments. There can be human biases. Different reviewers can have different perspective and come up with different conclusions on the same type or similar application. And the process doesn't scale. You need to hire more and more underwriters linearly as the application grows on scale. Now, how does machine learning fit over here? Machine learning models can automatically assess such merchant risk by analyzing a comprehensive set of factors like the business side, the category, the financial history of the merchant, the credit scores, ownership information, transformation pattern for the similar merchant, and also some extra source of data that we can get from online reviews or from public records. And these exhaustive testings or exhaustive record collections cannot be manually assessed by a human, which is going to be a cumbersome task for them, and it might take days or weeks to collect information across different sources that are available online. The models have to be trained on thousands of previous applications, learning which factor correlate with the merchant success and which indicates elevated risk. This can make instant decisions for straightforward cases. Lower risk merchants get approved immediately. High risk merchants can get declined with clear reasoning and documentation. Interesting cases, probably the edge cases where human judgment truly adds value, gets routed to the experienced underwriters with the model assessment and key factors highlighted. This means a human expert, a man in a loop, spend their time where it matters the most, not on the routine evaluation. This impacts the business substantially. We typically see around 90% of reduction in processing time for standard application. Manual reviews decrease by 75% as most of are handled automatically. And perhaps the most important is that almost 40% of improvement in risk reduction. The model catches problematic merchants at scale that might have slipped through the manual review. But it's not just about speed and accuracy. Machine learning enables consistent decision making at scale, creating better user experience for merchants while maintaining appropriate risk controls. Now let's move on to the transaction processing life stage of payment systems. The demands are even more extreme, I would say. Payment authorization happens in milliseconds, and it has to happen in milliseconds to have a better customer experience. When someone swipes a card, for example, or clicks buy now, the system has to make a decision within a few milliseconds, whether to approve or decline the transaction. Within those tiny window, you need to make distinguish a legitimate transaction, whether it's a fraud, without adding friction to the customer experience. Static rules create dilemma, and if it's not governed or doesn't go to the review cycle, and if it's too strict, you decline legitimate purchases and frustrate the customer. If it's too lenient, you let fraud through the system and lose money. Either way, you're making business trade-offs on incomplete information. And most of these manual transactions or manual rules are exposed, easy to understand, and easy to break for middleman attacks. The challenge intensifies because fraud patterns constantly evolve. What worked last month might not work this month. Fraudsters test the system in and out, find the weaknesses, and try to exploit them as much as they can. By the time you update the rules, they have moved on to the next tactics. Machine learning transforms this equation. Real-time machine models score every transaction based on hundreds of features. They look at device trends, geolocation of the customer, velocity patterns. Is this the 10th transaction for this card in the last few hours? They consider merchant categories, historical behaviors, or even the time of the day when the transaction was made. The model continuously learns from its feedback. When the transaction is approved and later reported as a fraud, the information flows back to improve the future predictions, and that's where the deep learning model comes into play for fraud detection system. When a legitimate transaction has been declined, the customer calls to verify that and teaches the model that it's a legitimate transaction and should not be a fraud transaction. So it backpropagates all the rules and decision making back to the machine learning layers, hidden layers in deep learning model, and that's when this makes the system more smarter over a period of time. And we'll see lesser and more enhanced user experience through less friction. The result is a set of key machine learning capabilities in real-time processing. Actually, the fraud scoring assesses the risk in less than 100 milliseconds, providing a probability score rather than a binary decision. For example, if a fraud has been detected and it falls within the category of 0.5 to 0.7, there needs to be an enhanced customer validation for this transaction. And if it's beyond 0.7, it's a clear, legitimate fraud transaction that has happened, which has to be tagged. Routing such intelligent decisions optimizes approval rates by selecting the best payment networks for each of these transactions based on the historical performance. Anomaly detection, identification, unusual patterns are detected instantly. Perhaps there are sudden spikes in the transaction for a particular region. A specific merchant is seeing unusual card testing activity. And dynamic thresholds adjust rule based on the context. What's normal for one merchant category might be suspicious for other merchants. All of this happens in real time at scale with accuracy that exceeds the rule-based systems that could achieve. And that is the power of machine learning in transaction processing. The third application area is the operational decision making, which is often less visible but equally important. Payment platforms generate massive amounts of operational data, system metrics, performance indicators, error rates, resource utilization. The volume is overwhelming. Human teams struggles to monitor all of this at real-time, spots emerging issues before they impact the customer, and make optimal decisions about capacity and resource allocation. Traditional approaches are very reactive. You notice a problem after it affects the customer and then scramble to fix it. Or you over-provision the resources to be safe, wasting money or having utilized capacity. Neither approach is optimal. Machine learning enables the fundamentality of different models actually. Instead of reacting to a problem, machine learning system predicts it. The model learns from the normal pattern of the system behavior and detects anomalies that indicate potential issues. They forecast traffic patterns based on time of the day of the week, upcoming events, and the historical trends. This enables proactive operation. The system can scale up capacity before a traffic spike hits. It can identify the performance degradation before it causes outage. It can optimize resources, allocates dynamically, ensures your capacity where you need it without over-provisioning the resources. Let me give you a specific operational use case. Like for first, the capacity plan. More machine learning models forecast load patterns and trigger auto scaling decisions. They optimize resource distribution across infrastructure and also ensure efficient utilization without sacrificing the performance. The second is incident detection. Anomaly detection algorithms spot issues in real time and generate intelligent alerts. Like a root cause analysis model helps teams to quickly identify what's wrong. Some systems can even trigger automated remediation process, like resetting failed services, rerouting traffic, or even adjusting configurations. And the third one is about performance tuning. Machine learning models continuously monitor latency, identify bottlenecks in the transaction processing, and suggest or automatically implement configurations that can optimize the throughput and response time for any transactions that rely on the machine learning algorithms. The resulting payment platform is just not about running the system, but it is about continuously improving its own operations with minimal human intervention. This not only enhances the customer capabilities of using the payment platform, but also has less friction of humans getting involved in the process of maintaining the system. Now let's step back and look at the system level benefits that machine learning brings to the payment ecosystem. These transcend individual applications and transform how the entire platform operates. First, the scalability. Machine learning algorithms enables payment system to handle millions of transactions without linear cost increases. Think about for a moment, like traditional systems have to scale linearly. Twice the volume requires twice the infrastructure and twice the staff. Now, machine learning over here breaks this pattern. Models that have handled increased volume without degradation in quality, they quickly adapt to traffic spikes, automatically adjusting to processing priorities and resource allocation. This enables global expansion without the proportional team growth. You don't have to constantly keep hiring people just because your traffic is linearly expanding. You can enter into new markets, support new payment methods, and handle growing transaction volumes without hiring an army of analysts and operators. Machine learning algorithms are quite capable of performing analytical skills at scale and give more insights and forecast for the transactions that are happening within the payment system. Now, moving forward, the second one would be automation. This is perhaps the most tangible benefit I see while using machine learning. The machine learning reduces manual intervention from 50% of cases in traditional systems to less than 5% when you're using a machine learning enhanced ecosystem. Most decisions like fraud checks, risk assessments, routing choices happen automatically with high accuracy and at scale. This frees human experts to focus more on complex edge cases where judgment and creativity matters, and this ensures that there's man in the loop in the entire machine learning model's learning skills. The payment analyst isn't just reviewing hundreds of routine transactions, but they have been investigating sophisticated fraud rings or making strategic decisions about risk policies. The platform operates 24/7. You don't have someone just stepping out because he needs to have dinner and when the system is not being monitored for a while. So those kind of anomalies can be avoided when you're using machine learning at scale because it's going to operate 24/7 without any human intervention. And it still maintains a high quality and appropriate risk controls. Now, the third one I would say is more about low latency intelligence. Machine learning enables real-time decision making under 100 milliseconds, even when processing complex feature sets with hundreds of data points. The model maintains a high accuracy throughput, handling thousands of transactions per second without compromising on decision quality. And that's the magic and power of machine learning in payment systems. This is critical in payment systems, and then milliseconds really matter, because when you swipe a card at a merchant location, you want the transaction to happen quickly. So every milliseconds of latency will affect the customer experience and the conversion rates. Machine learning achieves this seamlessly and with sophisticated intelligence, internet speed. These three benefits, the scalability, automation, and low-level latency intelligence, represents a fundamental shift in what's possible with payment platform. They enable business models and customer experiences that weren't feasible with transaction approaches. Now let's move on to the machine learning ecosystem view. I want to give you a conceptual framework of thinking how machine learning fits in the payment ecosystem. This diagram shows machine learning not as a feature or an application, but as a foundational layer. At the bottom, we have the data layer that includes all the raw data, transaction data, event streams, user behaviors, system metrics, and various other data points. In the payment platform, the data is incredibly rich. Every transaction, every authorization decision, every fraud report contributes to the learning process. Now, above all that sits is the machine learning intelligence layer. This is where the data becomes more insight and insights become more of an action. The model processes incoming data in real time, generates prediction and scores, identifies patterns and anomalies, and enables automated decisions. This layer acts as a central nervous system for the payment ecosystem. Now, the application layer sits on top of the machine learning intelligence. This includes all the visible payment functions like payment processing, fraud detection, analytical dashboards, operational tools, API interactions, and each of these applications leverages the machine learning layer for their intelligence needs, but the intelligence itself is centralized and shared across all these different functional and operational areas. Finally, at the top of the business layer, we have the merchants, the customers, the partners who interact with the payment platform. They experience the benefits of machine learning algorithm through faster onboarding, smoother transactions, and better fraud protection, and more of a personalized service using association relation using in machine learning. The key insight here is that machine learning intelligence layer connects everything. It transforms raw data into more of an actionable intelligence that powers all the applications above it. It enables the applications to be faster, smarter, and more adaptive than they could be independently. The architecture view helps explain why machine learning is transformative in payments. It's not just about improving individual features, it's creating a new foundation that elevates the entire ecosystem. Now let's go over the challenges and consideration. Of course, machine learning adoption in payment is isn't without challenges. Let me be clear about the considerations and potential pitfalls, because understanding this is crucial for any successful implementation. First, the data quality and availability. Machine learning models are only as good as the data they are trained on. In payments, you face challenges like missing data. Not every transaction has the complete information, biased samples. Your training data might not represent all the customer segments equally. The data quality issues like errors or duplicates and inconsistencies that could undermine the model performance. Secondly, I would say the model explainability. In financial services, you can't just deploy a black box model and hope for the best. Regulatory requirements demands transparency. You need to explain why a merchant was declined or why a transaction was being flagged. Business stakeholders need to understand the trust and how the model is making decisions. They require balanced model sophistications with interoperability. Now, the third is the real-time constraints. Payment decisions happen in milliseconds, which puts several limitations on the model capabilities and complexities. You can't run an ensemble of deep learning networks if it takes 2 minutes or more than 5 minutes in making the computation. Models must be optimized for latency without sacrificing the accuracy. This means that using simpler, faster models or implementing sophisticated caching and pre-computational strategies. So that limits the machine learning capabilities if we are using at real time, where the latency is the utmost priority for having a better customer experience. Now, fourth is about continuous monitoring. This is often underestimated. And to be frank, it's not once you have defined the model, developed the model, you have pushed into the production, and your job is done. And that does not stop over there. Fraud patterns evolve daily, customer behavior shifts, and there are new and new regulatory environments that change. So, considering all these different factors, a model that performs well today might not be performing or degrade in the next quarter. You need to have a robust monitoring to detect performance degradation, automate restraining pipelines to keep the models current, and have many or robust alerting systems to flag when human intervention is absolutely needed. Now, fifth comes with the integrational complexities. Payment platforms are complex, often involving legacy systems that weren't designed for machine learning algorithms. You need to integrate machine learning systems with the existing infrastructure. And you have to maintain its backward compatibility, meaning, for example, if a machine learning model does not work for a particular service, it has to be refactored and should have a fallback mechanism to the traditional rule-based models. And that basically puts a lot of constraint when we are often involving legacy systems that basically weren't designed to use machine learning algorithms. You might need to integrate machine learning systems with the existing infrastructure, maintain backward compatibility, meet compliance requirements, and also ensure a fail-safe operational environment. This integration is often more challenging than I would say than building the model. Finally, when you talk about risk management, errors in payment systems have real financial impacts. A bug in a fraud model could cost millions. And overly aggressive risk models could decline legitimate customers and harm the revenue. This demand robust fallbacks, human oversights for edge cases, and careful validation for deployments. The stakes are high, and you need to balance innovation with appropriate caution. The challenges are real, but they are not insurmountable. Successful machine learning models adoption in payment system requires thoughtful consideration of these factors, not just a technical expertise in machine learning. What is the future of machine learning in payments? Looking ahead, where does machine learning in payments heading to? Let me share some trends that I believe will shape the next generation of payment ecosystem. First is the embedded financing. We are seeing payment experiences across embedded devices seamlessly that are getting used on a day-to-day application, like ride sharing, food delivery, social media, gaming, and so many different industries. Machine learning is what makes this possible, enabling instant underwriting, real-time fraud detection, and personalized payment options within the derivative context. The payment becomes invisible if handled intelligently behind the scenes. Now, moving on forward, the second option is real-time personalization. We are moving more just beyond fitting one size payment experiences moving towards more of a dynamic offering, pricing, and experiences tailored to an individual user. Machine learning enables this by understanding the customer preferences, predicting what offers they will value, and optimize the payment experiences for conversion while maintaining the appropriate risk controls. And with the advent of more and more usage of agentic AI, we are seeing the machine learning algorithm plays a vital role in shaping the agentic AI experience, where the users have more of a personalization and do a better shopping experience using agentic AI framework. Like, for example, he may just say, go ahead and do the purchase in a TJX store and get me a video game console. So the agentic AI has to make an intelligent decision, given that banks can have more of a private label credit cards or dual cards, and it has to pick up the right credit card, which is going to give him more reward points when he purchases on a TJX store online. And the agentic AI has to make intelligent decisions using machine learning algorithms to pick up the right credit card and do the purchases behind the scene. Now, moving on, the third will be cross-border intelligence. As commerce becomes more global, payment platforms need to be more smarter, routing transactions across international networks, dynamic concurrency optimization, and as well as automated compliances with diverse regulatory environments across the globe. Machine learning helps to navigate these complexities, making cross-border payments faster, cheaper, and more reliable. And one such example, the banking system that I'm working, we are now started using stablecoins as part of the cryptocurrency world, and we have infused into the machine learning algorithms for quicker cheaper and more reliable way of transferring money from one institute to the other banking institute. Now, the fourth point would be alternative payments. The payment landscape is fragmented, to be honest. We have cryptocurrencies, we have buy now, pay later, we have digital wallets, and new methods we haven't imagined yet, like NFCs or push provisioning. And there are different ways of payment systems that are being proposed as part of the emerging payment system ecosystem. Machine learning enables payment platforms to adapt to these new methods quickly with the right tools, assess the risk profiles, optimize routing decisions, and provide a unified experience across diverse payment. Now, the fifth one would be more of an autonomous operation. As we are moving towards self-healing systems that predict and resolve issues before they are impacting the customers, machine learning enables these platforms to detect anomalies, identify the root cause, implement the fix automatically, and continuously optimize their performance with minimal human intervention. These aren't science fiction. We are seeing early implementations of all these capabilities as of today. The future of payment is more intelligence, more adaptive, and have a more seamless experience that we have now, and machine learning is the enabler. The key message here is that machine learning is not just for improvement in payments, it's redefining what's possible in the payment ecosystem. It's enabling business models, customer experiences, and operational efficiencies that weren't visible before. Now let's move on to the key takeaways. To summarize the key takeaways for this session, first, machine learning models is the foundational layer in modern payment ecosystem. It's not just an add-on feature going forward. It's not something that you bolt onto the existing system. It is a new architecture layer that transforms how an entire ecosystem operates. Second, that way machine learning enhances every stage of the payment lifecycle, as we have seen, right from the acquisition to the settlement to the operations. They are not part of just the payment journey, but machine learning touches every aspect of the entire payment lifecycle. This comprehensive integration is what makes it so powerful. The third is the system level benefits that we have seen in terms of scalability, automation, and low-level intelligence that are transforming the payment industry. They aren't incremental improvements. They represent the fundamental shift in how payment platforms can do and how they operate. Now, the fourth one would be the success that requires a thoughtful consideration of the data quality, explainability, integration, and the risk management. Machine learning is powerful, but it's not the magic wand. Successful implementation demands attention to these practical challenges. Finally, we have seen that machine learning enables platforms to evolve along with emerging technologies and customer expectations. It's not a destination, but it's a journey. Continuous learning, continuous improvement, continuous adaptation to the changing landscape makes the payment ecosystem more reliable, more trustable, and seamless experience for the customer. The payment industry is undergoing a transformation, and machine learning is part of it. Whether you're building a payment system using them or making decisions about them, understanding machine learning roles in the ecosystem is essential for navigating the transformation successfully. We move on to a quick demo on the fraud detection system. And here's a simple demo that I have promised earlier. So I have a Docker that's running on my local. So I have Kafka that's running. I've basically downloaded from the public repository. It's running locally on my system. I have streaming producer on my local, and event consumer that I have written. It's a small Kafka program that I have written. So basically, this is the model creation code. It's a simple code. I'm synthesizing the data. I'm not using any real-time data, synthesizing the data. So for a few of the data elements that I have, if the amount is greater than 3,000, I'm just adding the score as plus 3.5. And these are all like adding some weight to the fraud transaction. And over here, I'm returning it as one if the score is more than 60%. So if the cumulative data, if it's the amount is greater than 3,000, device trust score is less than 40. If it's an international transaction, if the fraud count is greater than 2. So they are all going to add up to the score. So if the score is more than 60%, I'm going to, it's 1 or 0. So this is how the model gets trained. And it packages into the PKL file. You will see over here, the PKL file over here. And what basically, so this is a generator. So I'm randomly generating data on the fly, like amount leading from $10,000 from $1 to $5,000 transaction areas, randomized, all this data randomized. I'm randomly selecting the location. And what I'm basically doing is I'm generating these transactions and I'm sending it to a Kafka topic. So this is how I would send the data. And when I'm basically consuming the data from the Kafka stream, I predict the transaction. Basically, I use the model that I had built before. You will see the model has been loaded out here. And these are the feature sets that are there as part of that. And I'm using the model to predict the transaction. And if it is one, basically if the prediction is one, I'm saying like the transaction is a fraud transaction, else it goes through without identifying this fraud. I'll go ahead, I start the fraud transmitter. Basically, it is just generating the transactions, and I will be consuming those events. So if you look at the consumer side, yeah, if you look at the consumer side, you'll see that the data is getting consumed. Not all the transactions get tracked as fraud. It is a combination of data, and I probably pause this. So it is a combination of data. So if you look at this particular transaction, the amount is greater than 3,000, the device code is less than 40, and it's an international transaction. So this gets tagged as a fraud, and it basically identifies as a fraud transaction. And this gets propagated into the downstream system. Very simple program. Thank you for your attention. I hope this session has given a clear understanding of how machine learning fits into the current payment ecosystem and why it matters for the future of digital payments. I'll be happy to take any questions. Feel free to reach out to me in the LinkedIn URL that I have given in the slide. I will be more than happy to answer any questions. Anything like specific to application, implementation challenges, technical details, where you want to see which kind of machine learning model can fit your use case, where you see opportunities in your own context. I'll be more than happy to understand your use case and see how machine learning can fit seamlessly into your operational model. Thank you again, and I will look forward for any discussion that you have at this point. And thank you for Conf42 for giving me this opportunity to speak in a wonderful audience. Thank you all.